All right, example 2. Let's talk about finding the equation that would represent the slope of the graph at any point in time, not just maybe the point 1, 3 like this picture or the point -1, 1. Let's just talk about how would I find the slope at any one point in time. So I'm still going to use that same formula that we were given at the very start of the lesson, that the slope will equal the limit as h approaches 0 of f of x minus h minus, excuse me, that's a plus, f plus h right there, minus f of x divided by h. You can see now that my formula, it's the same one I used on example 1, and it's the same formula given here as the instantaneous rate of change. So what am I going to do this time if I don't have a point to plug into? Well, I'm still going to plug this into my equation. So when I plug in here, I will have the limit as h approaches 0. And what I'm going to plug into my equation, again, they call it a y, we could call this f of x, is I'm going to substitute in here x plus h quantity squared plus 2 times x plus h, and then we're going to subtract f of x, which means I need to subtract this whole equation. So I'll put in these brackets to make sure I subtract the whole equation, but just plugging in an x in there. So x squared plus 2x, all this over h. And now we go to simplify. So I will FOIL again over here, just like I did in the last problem, FOIL. We'll have x plus h times x plus h. When I FOIL that out, we will end up with x squared plus x times h, which I'll call hx, plus another hx plus h squared. That cannot be reduced. So we'll say the limit as h approaches 0, that front portion will just be x squared plus 2 hx's plus h squared. That's this front portion. And now I'll distribute this. Let me switch colors so you can see I'm now distributing this plus 2x plus 2h. And then finally at the end, I will need to distribute the negative through. Minus x squared minus 2x. Now all of this will be over h. So now if I go to simplify, I can say, okay, I see I have a positive x squared and a positive x squared. Those will simplify together. I have a, let's see here, a positive 2x and a negative 2x. Those will simplify together. And so it seems to me that the limit as h approaches 0 would be h squared plus 2hx, h squared plus 2hx plus 2h, all divided by h. Again, I have a common denominator, or common factor in the numerator, a greatest common factor of h. So I could simplify this by saying this limit as h approaches 0 is equivalent to, if I do a GCF here, h I would divide out, so I'd have h plus 2x plus 2 all over h. And we can see that these h's would simplify with one another. And so now I'm saying, what is the limit as h approaches 0 of h plus 2x plus 2? I do a direct substitution at this stage. If I do a direct substitution, because this is now polynomial, I get 0 plus 2x plus 2. And so since this is my slope all the way down, my slope, I've now come up with my slope. And really, this is more than a slope. This is going to be the equation at any point in time. So that looks like a slope here. What that means is the slope itself will be 2x plus 2. The slope will be 2x plus 2. So whatever x value you choose, you will be able to find your equational line from there. Again, if I wanted to use the equational line using point slope form, that's supposed to be a k equals m times x minus h. Okay, now let me show you graphically what's going on here. Now that we know the slope, what I'm going to do is I'm going to graph this function here as given, y equals 2x, no, sorry, x squared plus 2x. And that's the function itself. And we said that the tangent line here, the slope, I should say, the tangent line, or the instantaneous rate of change can be determined using the formula ma equals 2x plus h. But here's what I'm going to do. I'm going to substitute an h in here, and I'm going to get two variables, h and k. And to make it a slider, I got to say like h equals 0, k equals something. Okay, so what I have in here is the slope, but instead of using the value x, because x is reserved for this x-axis, I'm going to use the letter h. So at any point in time, what I should have is this tangent line that's going to go through the point using this as a model, using h and k, y minus k equals m, the slope of the tangent line, times x minus h. And one more time, looking at this graph isn't exactly accurate. It should go through the origin, which it doesn't. This one does. Okay, as long as I line up this on any point that hits this parabola, you will see the tangent line at that point. Now, this calculator will automatically calculate it for us. And so I'm going to get a table here so we can see the points on this graph, and we're going to find tangent line. So for example, if I wanted to find the tangent line through the point 2,8, what I'm going to do is change h to be 2, k to be 8. And what happens is this purple line, because we had the formula typed in, it's programmed in like this, you see that the tangent line would come through right here, and the slope of the tangent line would be 6 at the point 2,8. Now, what if we wanted to find what's the slope of the tangent line at 1, 3? Well, I would just change this to a 1 and this to a 3. And now you can see, according to this formula, that the slope would be 4 at the point 1, 3, which is what we have over here. The slope is 4 through the point 1, 3. Let's check this point. When we look at left 1, down 1, you see that the slope is constant, meaning it has a slope of 0 through the point -1, 1. And so this represents it all the way around. If we wanted to find another point, like say this one right here, it looks like to me that's left 3 units, up 3 units. You can see left 3 would go up 3 right there. If I wanted to try that point, -3 and 3, you can see that the slope of this line would be -4, the slope of the tangent line going through the point -3, 3. Now this would work for everywhere as long as you're choosing a point that's on the graph. If we get a point that's not in the graph, obviously now this would not be calculating a tangent line, but as long as it's a point that's on the graph, which like -3, 3 was, this little calculator over here, the way I designed it, would work. Where I typed in the equation, I just started off with the equation itself. Once I hit table, it changed it. I just did y equals x squared plus 2x here and change it to a table. The equation of a line and point slope, and I added the variables h and k and m to calculate the rest. Now, you have one. You can try pause the video if you need more time. You should be able to, if you want to use digital, the technique I did right here, or you can go through the algebra as we've shown using limits.